for being here tonight. When we were putting the chairs out, I was wondering, oh, there are way too many chairs. But no, I think people are standing in the back. So thank you very much for coming. And I acknowledge being on First Nation territory. We live in a beautiful land. So as was presented in the introduction, I was retained by the committee to have a look at the document, look at the technical documents, and give my opinion. I am a professional engineer, and I am a hydrogeologist, so that means my expertise is groundwater. And I've been a consultant for roughly 30 years dealing with groundwater issues. So my slides are going first to present the setting, and then we'll talk about sensitive receptors and issues. When we look at groundwater, it's always important to see, okay, how is it moving, where is it moving, and where is it discharging to? And this is what we call the sensitive receptors. So I will go through the work that Upland and its consultants have done, and then I will come up with some remaining questions, things that we still need to solve. So let's start with the setting. So this is a map which shows Upland, shows Rico Lake, connected to McIvor Lake, and this whole system is a drinking water system for Campbell River. So the water flows in that direction, up here, and then toward the ocean. And this is where you have the water intakes. We have the landfill here, and then we have a valley down that goes toward the Quinsam River. We have Coal Creek, and we have the Quinsam River hatchery right here, with the city of Campbell River being by the foreshore. Now we are zooming. We have the Upland property with the red boundary. We have Rico Lake right here, McIvor Lake. And I've been involved many years ago looking at the situation of the regional landfill and trying to define the groundwater and the aquifers underneath the landfill. And so years and years of data have been collected. And based on the study in this area, we understand that groundwater is flowing from west to east, as indicated by my blue arrow here. Unfortunately, in BC, we still know very little about groundwater and aquifers. We have a handicap. We haven't mapped all the aquifers. We haven't characterized all the aquifers in the province. So if you go online and check what's available from the Ministry of Environment, you will find a map like that. And it shows we have the Upland property here. So we have Rico Lake, McIvor Lake, and they indicate the boundary of one aquifer. They indicate the boundary of another aquifer, and they have another aquifer here. Why do we have so few aquifers defined? Is because they take what's available from the water wells which have been drilled. So in areas where no water wells have been drilled, then we don't know about the aquifers. So south of the site and east of the site, as you can see, we are still in unknown territory in terms of aquifer definition. On that slide, I show the Upland property. The contours here, the brown lines, indicate the elevation contours. And you can see that there is a higher elevation, there is a hill south of the site. And bedrock is at very shallow depth. And so usually water will flow at surface and get into the cracks and get into the bedrock in bedrock aquifers. We have typically two types of aquifers. We have what's called the overburden sand and gravel aquifers, and then we have the bedrock aquifer. In sand and gravel, the aquifers will be made of all the water which is between or in the voids between the sand and gravel particles. For fractured bedrock, the water will be in the fractures, in the fault and in the fractures of the bedrock. This is where it will flow. So here to the south, we have a null, and we are dealing with fractured bedrock. And to the east of the site, we mostly have deposit. We have sand and gravel. But as I mentioned, we don't know. So we know the boundary of the aquifer here, but we don't know about the boundary of the aquifers, how deep it is, how thick it is, or what it is. Now I'm just going to show a few slides which show, so now we are really zooming on the Upland property, which is on the right side of my slide here. And this is indicated with the squares here. This is the location of the proposed upgrade of the landfill. This is a map which has been produced by Upland's consultants. It shows the boundary of the property, and it shows with the arrows what will happen with rainwater, in which direction is it going to flow based on topography and based on drainage within the property boundary. You have here the location of the proposed, where the landfill would be built. So according to their map, there is a boundary with water flowing toward Rico Lake just west of that boundary, and what flows east of that boundary flows toward the site and toward the east. Let's address the issue of sensitive receptors. So of course, you're here because you drink water delivered by the water system of Campbell River. And as you know, Rico Lake is part of that reservoir. The other sensitive receptors consist of the aquatic ecosystems, which rely on the groundwater and rely on the small streams and small tributaries of the Quinsam River and Cold Creek, which discharge or pass through the Quinsam River hatchery. So we are dealing with a very sensitive ecosystem or series of ecosystems. Let's address what was done as part of the application by Upland. So they needed to define and describe as well as possible what's happening with water on their site. So they have drilled monitoring wells, indicated by the black dots, to identify what type of soil they were finding, how thick were the soils, where they hit bedrock, etc. Based on that information, they produced maps. One of the maps indicates the contour of the topography of the bedrock. So on the south and western side of the site, so we have outcrops of bedrock. So these complex lines show the top of the bedrock. And we have a lower elevation bedrock corresponding roughly around here. Rico Lake is located right here. There is also another null of bedrock here to the northwest of the site. I remind you that the boundary of the site, the western boundary, is right here. Based on the information collected in the monitoring wells, defining where the sand and gravel was and how high the water was measured in the monitoring wells, they defined the surface of the water table in the sand and gravel aquifer. So the surface of the water table is indicated by these blue lines. So you are used to topo maps which show the ground elevation. So this is exactly the same, but in terms of the ground, it shows the water table. And groundwater will move from high elevation of the water table to low elevation of the water table. We have higher elevation water table here, and as you move to the bottom right corner, so to the southeast of the slide, the elevation of the water table drops. So the profile of these lines and the location of these lines has been drawn by Upland's consultants. And based on that, they consider that the water moves in the sand and gravel as indicated with the arrows, the blue arrows that you can see here. So water moves roughly like that through my slide. This is in the sand and gravel aquifer. This is a cross-section which goes northwest to southeast, so across the site, and with McIvor Lake on the northwest side. And the gray layer indicate the presence of sand and gravel. And this line shows the top of the bedrock. As I indicated, they have drilled wells, and they have measured water levels indicated with the little blue triangles. So this is the elevation of the water table. This is sand and gravel. You have dry sand and gravel up to that depth, and then you have saturated sand and gravel below the blue triangle. Based on that information, they came up with illustrations which show the movement of water in the sand and gravel. So we have to the west, this is west, this is southeast. We have Rico Lake, McIvor Lake, Rico Lake. This is the footprint of the Upland's property between this point and this point. There is what they assume is the rock, a bedrock boundary, a bedrock ridge here. And then we have sand and gravel with the elevation of the water table indicated by this dashed line. And the blue arrows indicate the movement of the groundwater in the sand and gravel aquifer. This is another cross-section going from north to southeast, starting at McIvor Lake. Same thing with the presence of the overburden, the estimated boundary or top of bedrock, and same thing with the zone which is saturated where groundwater moves to discharge at lower elevation and to the east in the watershed. In their application, they're also proposing locations where the water table will be kept monitored, and also where water samples can be collected and analyzed for water quality analysis. So the red circles indicate the locations which are being proposed for long-term monitoring. So what are the key questions? First, I think there is still a lot of unknown about how the site connects to its surrounding. The studies have focused on the site itself, but there's still a lot of unknown outside of the property, both to the east, between the property and the river, and also between the site and Rico Lake. And my next slides will illustrate the key remaining questions. When I started reviewing the file, I realized that some of the monitoring wells were drilled into the bedrock. A few of them, but some of them. And where we have information about the groundwater in the bedrock, the data indicate that the groundwater in the bedrock is under pressure. So the groundwater flows upwards from the bedrock to the sand and gravel. And when you take information about the groundwater flow in the bedrock, this is what you have. You have a high elevation right here. And then you also have information about the pressure in the bedrock at this location. So the water table here in the bedrock is close to 186 meters. And the elevation at that location is 165. So my red lines indicate the shape of the water table in the fractured bedrock. My arrow indicates the direction of the groundwater in the bedrock. So you can see that this direction is very different from the direction in the sand and gravel that we described previously. So we have two aquifers. We have a sand and gravel aquifer with water moving from here towards the corner of my slide. And then we have a different aquifer, the fractured bedrock aquifer, with water moving in a different direction, in that case, almost straight to the north. That wasn't in Upland's application. They haven't addressed the flow in the bedrock. Why is it an issue? Because in bedrock, water will follow the fractures. And you have seen bedrock, the fractures are not always parallel and well-aligned and squared. They go in every direction. So my slide here indicates potentially directions of key fractures that would be open, that would be allow movement of groundwater. And groundwater will flow from high water table elevation to low water table elevation. So here I am, my higher reservoir in my fractured bedrock is located to the south. So water may flow, as indicated by my blue arrow. It will flow here, and then it will flow along that fracture. It may flow like that in that fracture, and then we have 180 meter elevation in the lake. We have 186 meter elevation here in the fractured bedrock, right? So it may flow according to this scenario. I don't know if it's true or not, but you could also yourself draw some lines. We don't know what the key fractures are. It hasn't been investigated, right? So for me, it's an unknown. I may be wrong, or I may be right. If I am wrong, it's okay. But if I am right, we may have movement of groundwater through the site towards Rico Lake. Upland is proposing, and in the review, there's been request from me and also from a third-party reviewer that reviewed on behalf of Upland for the ministry. And it was recommended that monitoring wells be completed in the bedrock to define that, to better understand. And Upland said, we'll do it, but after we get approval. And that's the location where they would put a well. So I just described my concern and the questions that I still have for movement of groundwater in the fractured bedrock. My other concern, when I looked at the file and I looked at the completed work, is in this whole quadrant of the site, we don't know the situation about groundwater because there is no drilling, there is no monitoring wells. So the assumed direction of the groundwater by Upland is as indicated by this arrow from the northwest to the southeast. However, based on my understanding of the studies that we did to the east when we did the study of the original landfill, my feeling is that groundwater is flowing more straight to the east and not to the southeast. So we need to understand what's going on in this quadrant of the site and also to the east of the site to make sure we have a proper understanding of the direction of the groundwater flow in the sand and gravel aquifer. Because unfortunately, as you can see, most of the wells can align along the same axis. So we don't have a good distribution of the monitoring wells to have a thorough understanding of the direction of the groundwater in the sand aquifer. Uplands have done some studies to look at where is groundwater discharging to surface and where would be the first locations where sensitive ecosystems would be found. And they have to follow some protocols, contaminated sites regulations protocol. So there are some distances that they have studied, and they have done that. But still, for me, there is a question of how sensitive is ecosystems and what type of contaminants may be released. You can model the movement of metals, heavy metals in groundwater. You can model the movements of hydrocarbons in groundwater, but there are some type of contaminants that will migrate faster and further, like pharmaceutical products will release molecules which can migrate long distances. Those type of products are not supposed to be in the landfill, so they haven't been targeted and they haven't been taken into consideration. So I think we have to be very careful of what our plans propose to dispose in the landfill and what they have disposed in the landfill. And this is something, I mean, it's outside of my review, but this is something that you should be aware and should be concerned about. And I'm sure we'll address those questions later. Again, we are still very ignorant about groundwater. And I think it's important that we use the right measures to reduce this level of unknown, because the decisions that are going to be made will have a long-term effect. And it's very important that we do all our homework to reduce the risk of impact to sensitive ecosystems. My wrap-up slide indicate that studies have been done, but critical gaps remain. And I have tried to illustrate them through my slides with the fractured bedrock, which still need to be properly characterized, and the direction of the groundwater in the sand and gravel that also needs to be really better defined. Role played by fractured bedrock aquifer, because of that locations of the fractured bedrock and because of its proximity to Rico Lake, this is a highly sensitive zone and a highly sensitive area that needs to be better defined. Groundwater in the sand and gravel aquifers discharge into sensitive aquatic ecosystem. The groundwater regime still to be defined. I thank you very much for your attention.
We're going to take about 15 minutes worth of questions now. And what I would like to say is that, one, if you could frame your question, brevity is important because there's probably quite a number of people that would like to ask Dr. Wendling or others questions, if you could do that, and also ask them respectfully.
How do you explain to this meeting, please, the diametric difference between professionals such as yourself and professionals hired by the Upland's company in connection with their proposal?
Uplands have hired professionals. They have hired a company which has, a good name in the profession. the reports were signed by registered professionals. But hydrogeology is a very complex science. I'm learning every day in my job. So whenever work is being done, there is a budget associated with the work. And in the case of consulting firm, they will have most of the legwork done by more junior engineers. And then a few hours will be assigned to senior engineers, which we will review the reports and sign the report. So what I found when I reviewed the work, one of my junior engineer wouldn't have found because of the experience, because of the eyes. I have worked over 1,000 projects in my life. And so the fact that I looked at those data, and when I looked at reports, I go straight to the appendix where the core of the information is. I looked at the logs of the wells. I looked at what water level was measured on that date. And then I caught this issue with the bedrock and with higher pressures, that there is something here that needs to be addressed. But the junior engineer of the other firm probably they say, okay, we just have 1 point to 2 points. It's not a big issue. Everything is in the sand and gravel. And I say, no. That's not my point of view. So it's why I'm throwing the ball back to their court and say, okay, now, I spent a lot of time. I looked at the details. Now do your job.
I'm Bill Williams from United Native Nations 510 here in Campbell River, and I've been here now for a decade. I was going to say 2 hours, but that's I'm kidding. No, I've been here about a decade now. My concern, first, I'll give the questions to you later because I know we have no time. But my main concern is not if, but when there's an earthquake, have we forecasted the damage, and how would we come up with repairing and whatnot? And also, Uplands, are they using our water to manufacture or do whatever they're doing?
I guess probably Terry.
Absolutely, yeah. Uplands gets its water from McIvor Lake for the cleaning and washing of grounds.
Yeah. From what I've heard, like I said, I've been here for a decade now, that the Upper Campbell River Lake especially is getting less and less water due to lack of rain and snow. So over a period of time, as the water flows, is there a forecast of Campbell River getting less water from our drinking reservoir? So that's...
I guess it's not... typically, in terms of climate change, what we are forecasting is typically more precipitation in the winter, stronger events, and drier summers, in a nutshell. But I'm not a climate change expert. I'm more a groundwater expert.
Yeah, because I do a lot of driving for our people to and from Gold River, and over the years, I've noticed that the Upper Campbell River Lake is like less and less water every year, and they rely on the rain and the snow to go into the water, and it's everything. But anyways, if you could answer the questions of not if, but when there's an earthquake, is there a forecast of?
Yeah, I think we are dealing with something that is going to be built. There will be a liner installed, and yes, there are criteria and level of resistance to movement associated with earthquakes. But it's true that liners, they have a lifespan. There will be some leakage, and this has to be also taken into consideration.
My name is Doran Anderson. I've been a resident here 20 plus years. I just wondered about your fractured bedrock slide there. The depths you're showing, are they depths above sea level to the surface of the water, or to the bottom of the hole, or what's the deal?
They are elevations, so it's elevations above sea level. This is by definition an elevation. So when I say 186, it's 186 meters above sea level.
Okay.
And when you say Rico Lake at 180, it's 180 meters above sea level.
Okay. So, but above that, there's already these sand and gravel aquifers that are a higher level, you've said.
You have a bathtub, and the bathtub is filled with sand and gravel, and then you have the bottom of the bathtub, which is fractured bedrock.
Porous, you could say, sure.
Yeah.
So when oil spills in the ocean, and people look at the flow, do they go down 500 feet to the bottom to see where it's going, or do they look at the top?
I won't talk about the ocean. I will talk about groundwater.
But oil floats on water, right?
Yeah. So what happens is you have some of the contaminants. You will have like a dilution. So if you have contaminants that leach due to rain and goes through contaminated sediment, soil, whatever, waste, and then reach the water table, then some of the molecules will dissolve quickly. Some molecules won't dissolve. Some molecules will float. Some molecules will sink. So you will have different behavior depending on the type and depending on the molecules.
Sure.
And then you have, as groundwater moves, some of those molecules will stick to the silt and the sand particle. In the subsurface, you have bacteria. So some of the bacteria will start changing the molecules, degrading the molecule. So you have many processes that take place in the subsurface and will control how far your contaminants will move.
Sure. Okay, thank you.
Little short guy. Hi, my name is Kelly Kovac. My wife and I moved here just 2 or 3 years ago. I'd like to thank you for the presentation, and I'd like to thank everybody for that provided us with this information, for bringing it to our attention. So I'm ex-military. I was a fighter pilot for many, many years. So I understand there's an issue, right? There's been analysis done. The city's accepted it. You know, one engineering firm has said this, and apparently it's acceptable to Uplands. And you've raised concerns. I don't begin to approach your level of expertise, and so my question revolves around, but once your concerns have been raised, what's the problem? Why aren't we investigating it further, digging another well, exploring, where the runoff is going to go? I don't quite understand. I've been trying to follow it in the paper, but I understand that. I understand that they want to do it after, so I'm saying, okay, what is the outcome? Like, what can we all do as citizens who obviously want clean drinking water to modify or mollify, the issues raised, so that, we obviously, nobody, and I'm sure Uplands doesn't want to poison anybody's water supply either. So where are we going with this, right? Right now it's obvious that we're at a stalemate. So can you comment on that a little bit, if you would?
Now I can comment on if you want to add to what I'm going to say. You are going through, and Uplands is going through an application and a regulatory process, right? So they had to submit an application. In that application, they needed to provide information. And the Ministry of Environment requested some information, right? So the committee was concerned and said, okay, there are some things that don't add up or that we need to confirm. So this is how we came to do the review, and our concerns were forwarded to the ministry, right? So now the regulator, they have information from both sides, and they have a chance to review that, make some comments, make some recommendations to the person at the ministry that will sign or not sign the permit. And there is also what's we call a referral process. So the city will also have a chance to give an opinion, yes or no, or yes with concern or no with concern, right? And so this is also where I think where you have some power, because you can express your own concern to the councillors, to the city. You can even write a letter to the Minister of Environment and say, you know, I want to know more. I live by the lake. I drink the water, whatever. So I think this is, as a citizen, you have some power. You can still say, you can push things in a direction because you have power. Nona, do you want to add to what I just said?
I really encourage everyone to look at the Campbell River Environmental Committee website and also to look at the Upland's website. They've posted all of their engineering data on their site as well. And I think that that will lead you to the most informed decision. As was mentioned, this is a very complex subject. There's a lot of unknowns out there. And we're currently going through a review of the current process. It was originally called results-based. Now it's called professional reliance. So when you propose to build a mine or a landfill or other industrial activity that may impact our environment, it's up to the proponent to fund the necessary science and engineering that goes into the development of their plans, their recommendations, which are forwarded to the appropriate ministry in the province, and in some cases to the federal government. So it's a change, and that change has happened now. I think it's around 20 years now it's happened. Some suggest it's kind of like the fox looking after the chicken coop. You've heard that? George Heyman, Damien and I met with the Minister of Environment, and certainly we have, there is concerns out there. That whole process of regulatory review and looking through professional reliance model is currently under review by the provincial government. So there's been some discussions around it, and Minister Heyman spoke to us and mentioned that there needs to be some checks and balances. And I think that that's what the public are looking for. So we're hopeful. We'll see where the NDP does go with that, but that's where we are right now. We can take one more question. Yes, we're going to have more questions at the end, opportunity as well. And Damien's going to make a brief presentation, but we'll take another question.
Thank you very much. I was born here. I have been here for 50 years. And I first of all want to thank Uplands for all of the service. We do appreciate that. I do want to mention that if some of us do not drink the water directly out of the tap, we all do brush our teeth and gargle with it, which we do enjoy doing. And also that when someone does eventually find that there may be a problem with leakage into our water supply, usually when this happens, it always ends up to be, from what my experience has been, a problem to clean up. Much bigger of a problem than what you anticipate initially, and also costing an awful lot of money. And I propose that maybe there is something else that I even have some suggestions of what you could do with the property, other than to put more toxic things in that particular area, just to err on the safe side, on caution, because you yourself use the water for teeth brushing or whatever reason. And I'm sure that there is different areas where extremely toxic things could be put within more of a reasonable area. I guess that's about all I wanted to say, and thank you so much.